So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation, that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture. Hello friends. So in the last lecture we studied about the single sideband suppressed carrier and their generation methods. So now in this class we will study about general expression of SSB SC. So to write the general expression of SSPSC, we know that M of t is our message signal, C of t is carrier signal, and carrier signal is always chosen as sinusoidal. So SSB of t in general can be written as AC by 2 mt cos omega ct plus minus AC by 2 mh of t sin omega ct. So this is the general expression of a single sideband suppressed carrier expression. And we have already proved that plus sign will always give us the lower side band and minus sign will always give us the upper side band. Now we know that to realize the SSB signal, what we will do, first of all we will generate the DSB signal. So this is our message signal. Minus omega m to omega m, and the DSB signal will be shifted to omega c and shifted to minus omega c. This will be omega c plus omega m. This will be omega c minus omega m. This is omega s DSB omega. This frequency is minus omega c plus omega m, and this frequency is minus omega c minus omega m. Now the single sideband expression will be, we will extract only one sideband. So I'm assuming that I'm extracting the upper sideband. So it will become omega c to omega c plus omega m and minus omega c minus omega m to minus omega m. So what is the bandwidth of MT? The bandwidth of MT here is omega m, and the maximum frequency component of MT is omega m. So what is the bandwidth of SSB? So the bandwidth of SSB is highest positive frequency minus lowest positive frequency. So it becomes omega c plus omega m minus omega c, or the bandwidth of SSB becomes omega m. So the general formula for bandwidth of SSB comes out to be, it is the maximum frequency component of MT. So whenever we need to find out the bandwidth of SSB, we will calculate the maximum frequency component of MT. Similarly, what is the power of SSB signal? So this is the SSB signal is written. So we will not calculate the power mathematically, rather we will calculate the power of DSB signal and we will half the power of DSB signal, because in DSB signal we are transmitting two sidebands and in SSB signals we are transmitting only one sideband. So the power transmitted will always be equal to one sidebands, and we are assuming that the power is distributed equally in both the sidebands. So the power of SSB will always be equal to the power of DSB by 2. Now if this mathematical expression is observed, it is written as AC by 2 MT cos omega ct plus minus AC by 2 MHT sin omega ct. So from here, if we want to calculate the power, so both these values, MT cos omega ct and MHT sin omega ct, occupies same frequency band.
So their power cannot be just added. So what we will have to do, we will have to assume that this is the signal S1t plus minus this is the signal S2t. Now to calculate the power, we have to use the formula. Power is equal to limit t tending to infinite 1 by t minus t by 2 to t by 2 SSB of t whole square dt. And we have to put the values here. So it will become minus t by 2 to t by 2 mt cos omega ct plus minus mht sin omega ct whole square dt. So the power formula will become limit t tending to infinite 1 by t minus t by 2 to t by 2 m square t cos square omega ct dt plus limit t tending to infinite 1 by t minus t by 2 to t by 2 m square ht sin square omega ct plus limit t tending to infinite 1 by t minus t by 2 to t by 2 2 times mt mht sin omega ct cos omega ct dt. So once the m of t is known, we will put m of t in this formula or we will calculate the power. And rather simpler approach is, whenever you have to calculate the power of SSB, just calculate the power of DSB and make it half. Now let us see what happens when m of t is single tone sinusoidal signal. So I am assuming m of t is cos omega mt and it is our single tone sinusoidal signal. So in this case, the Hilbert transform of this m of t will be am sin omega mt. We will provide the minus 90-degree phase shift, or we will simply visualize the integration of cos is sine to have directly written it as sine. So what is the general expression of SSB? The general expression is AC by 2 mt cos omega ct plus minus AC by 2 mht sin omega ct. So it becomes AC by 2 am cos omega ct into cos omega mt plus minus AC am by 2 sin omega ct into sin omega mt. Now, first of all, let me choose this plus sign. So this will become AC am by 2 cos omega ct cos omega mt plus AC am by 2 sin omega ct sin omega mt. So I am taking AC am by 2 as common and it becomes cos of omega c minus omega m into t. Let me draw the spectrum. The spectrum will have two impulses, one at omega c minus omega m and another one as minus omega c plus omega m, and the peak values will be pi into AC am by 2. So this is the spectrum. Now you can very well observe that both the impulses are below omega c and above minus omega c. So this is representing the lower sideband, and this we can already tell from here that a plus sign is chosen, then we are bound to get the lower sideband. What is the power of ST in this case? The power of this signal will be AC AM by 2 whole square divided by 2, or it becomes AC square AM square by 8. Now if you observe closely, what was the power in case of DSP? In case of DSP, the power was AC square AM square by 4. So you can say that the power of SSB is nothing but power of DSP by 2, or AC square AM square by 8. In this case, the message signal has frequency component FM, the carrier signal has frequency component of C, so the modulated signal has frequency component only one sideband, FC minus FM. So this is having only lower sideband. Carrier is suppressed and upper sideband is suppressed. So these two terms are suppressed already. Now in the next case, I am taking the minus sign. So the general expression becomes ST is equal to AC AM by 2 cos omega CT cos omega MT minus AC AM by 2 sin omega CT sin omega MT. So S of t becomes AC AM by 2 cos of omega C plus omega m into t. So let me draw the spectrum of this signal. The spectrum will become something like this. One impulse at omega c plus omega m, and another impulse is at minus of omega c plus omega m. And area of both the impulses will be pi into AC AM by 2. You can observe that these impulses are above omega c. That is why it is known as upper sideband, which we have already told. If we have observed here that minus sign will always result in upper side band. In this case, if we want to calculate the power of SSB, so it will become AC AM by 2 whole square by 2, or AC square AM square by 8, which is nothing but half of the DSP power. Also, if carrier signal has frequency component FC, message signal has frequency component FM, so the modulated signal in this case will have frequency component only FC plus FM, or the frequency component of upper side band. After having the discussion of single sideband suppressed carrier modulators, now let us try to discuss what is the SSB SC demodulator. So for the demodulation of SSB SC also, what we will use synchronous detector or coherent detector. So till now we have had very fair idea of synchronous detector or coherent detector. So in this case, first of all, I will make the diagram of the transmitter. At the transmitter, the message signal is passed through a product modulator or balance modulator or ring modulator. After that, we will pass it through a band pass filter. So here, this is the locally generated carrier signal, and locally generated carrier signal has expression of AC cos omega CT plus 0 degree. So this will be the output, and the output which come out will be SSB. Now this will propagate through free space and it will reach at the receiver. So the first block of the receiver is a multiplier, and at the receiver also we will have a locally generated carrier. This locally generated carrier will have some phase error and some frequency error with respect to the transmitted carrier. After that, it is passed through a low pass filter. The input of the low pass filter is XT and the output of the low pass filter is YT. The characteristic of the low pass filter will be such that its cutoff frequency matches with the band limiting frequency of the message signal. So this is the characteristics of the low pass filter. Now let us try to have some mathematical discussions. So we know that what is SSB of t. So let me make it as AC dash. So the SSB of t will be AC by 2 mt cos omega ct plus minus AC by 2 mht sin omega ct. What is the locally generated carrier? The locally generated carrier has AC dash cos of omega ct plus delta omega t plus delta phi, where delta omega is frequency error and delta phi is phase error, and I am assuming that both these errors are constant with respect to time, or they are not the function of time. So the signal x of t will become SSB of t into locally generated carrier. So it becomes AC by 2 mt cos omega ct plus minus AC by 2 mht sin omega ct. This will be AC dash cos omega ct plus delta omega t plus delta phi. So I will cross multiply it. It will become AC into AC dash by 2 m of t cos omega ct into cos omega ct plus delta omega t plus delta phi plus minus AC into AC dash by 2 mh of t cos omega ct plus delta omega t plus delta phi sin omega ct. So I will multiply and divide it by 2. So it will become AC into AC dash by 4 2 cos A cos B. So it will become 2 cos omega ct into cos omega ct plus delta omega t plus delta phi plus minus it will become AC into AC dash by 4 into, so m of t will also be here, so m of t I am writing outside. So it will become mh of t inside bracket 2 cos omega ct plus delta omega t plus delta phi into sin omega ct. So here I will use the formula of 2 cos A cos B, and here I will use the formula of 2 cos A sin B. So x of t becomes m of t AC into AC dash by 4. 2 cos A cos B becomes cos A plus B plus cos A minus B plus in the second term it becomes mh of t AC into AC dash by 4. 2 cos A sin B becomes sin A minus B, sin A minus B, so it will become delta omega t plus delta phi minus sin A minus B. So from here you can see that 2 cos A sin B and 2 cos A cos B. So I've used the formula cos A plus B plus cos A minus B, and in second case it will become sin A plus B minus sin A minus B. So after that it is passed through a low pass filter. When it is passed through a low pass filter, this has frequency of 2 omega c, so it is not allowed by the filter. Similarly, this sine term has frequency at 2 omega c, this is also not allowed by the filter. So what will be the output of low pass filter? The output of low pass filter will become mt by 4 AC into AC dash cos delta omega t plus delta phi plus minus of AC into AC dash by 4 mh of t sine delta omega t plus delta phi. So the output yt will become mt into AC dash by 4 cos of delta omega t plus delta phi minus plus mh of t AC into AC dash by 4 sine of delta omega t plus delta phi. So now let us discuss different cases. For case 1, I am assuming that the frequency error is 0 and the phase error is non-zero. So what will be the output yt? Yt will become mt into AC dash by 4 in first case we will use omega not equal to 0 and phi equal to 0. So this is the first case. So it will become mt into AC dash 4 cos delta omega t minus plus mh of t by 4 AC into AC dash sine delta omega t. So this output yt will become AC into AC dash by 4 into mt cos delta omega t minus plus AC into AC dash by 4 mht sine delta omega t. So from here we can see that this is the message signal and this is being multiplied by some time domain signal. So this term completely represents a distorted message signal, and along with an unwanted signal is present, so we will call it as interference. So as it was in the case of AM and DSB, here also when the frequency error is non-zero, we are not able to recover our message signal. Now let us discuss case 2. In case 2, I am assuming delta omega equal to 0 and delta phi not equal to 0. So what will be the output? The output will be AC into AC dash by 4 mt cos delta phi minus plus AC into AC dash by 4 mht sine delta phi. So from here you can see that this is our attenuated message signal, because this AC into AC dash 4 is also constant, this cos delta phi is also constant, so message signal is present here. But along with this message signal we are getting another time domain signal, which is Hilbert transform of message signal, or I can call it as interference. So in case of single sideband suppressed carrier, even if frequency is 0 and phase error is non-zero, we cannot recover our message signal. In case of AM and DSB, we were able to recover the message signal even when frequency error was 0 and phase error was present. But in case of SSB, if frequency error is 0 and phase error is present, in that case message signal cannot be recovered. Similarly for case 3. In case 3, we always talk about perfect synchronization. So for perfect synchronization, delta omega is 0 and delta phi is 0. So in that case, yt will be AC into AC dash by 4 m of t. Now if it is passed through an amplifier, then we can recover our message signal m of t. So in case of SSB SC, the message signal can be recovered only when transmitted carrier and locally generated carrier at the receiver are perfectly synchronized in both phase and frequency. If they are not synchronized with either of them, then we cannot recover the message signal. Now let us have a look on the case 4. In case 4, I am taking delta omega as 0 and delta phi as odd multiples of pi by 2. So what will be the output? So in this case, output will be AC into AC dash by 4 MT cos pi by 2 minus plus AC into AC dash by 4 MHT sin pi by 2. So the output will be minus plus AC into AC dash by 4 MHT, and it is not equal to 0. Though it is not equal to message signal also, but we can say that in this particular case we are not observing 0 output. The output is coming as minus plus AC AC dash by 4 MST, and it is not equal to 0. Or we can say that whenever the phase error is at quadrature between transmitted carrier and locally generated carrier at the receiver, in this case output is non-zero, or the single sideband suppressed carrier arrangement is not affected by quadrature null effect. So quadrature null effect at the synchronous detector is not observed when it is the part of an SSB SC arrangement. So to recover the message signal, what must be the condition? Phase error as well as frequency error both should be 0, or the locally generated carrier at the receiver and the locally generated carrier from the transmitter should be perfectly synchronized. Now in this section is very interesting. Let us understand the transmission and reception of voice signal through SSB SC arrangement. So first of all, I will discuss about the transmission. So we know that this is the voice signal, and voice signal has frequency range from 300 Hz to 3.5 kilohertz. So the spectrum of voice signal will be M of F versus F. This frequency is 0.3 K and this is 3.5 K. Similarly, this is minus 0.3 K, this is minus 3.5 K. So this is the spectrum of message signal. Now if you will observe this spectrum, so this spectrum is not starting from 0, but it is starting from 0.3 K and it is ending at 3.5 K. Similarly, voice signal is a real signal, so in the spectrum I have to show the negative frequency such that the magnitude spectrum remains an even signal. So what will be the spectrum of DSP signal? We know that to generate the spectrum of DSP signal, we will shift the entire spectrum by FC right side and FC by left side. So what we will do, we will shift the complete spectrum FC on the right side and also on the left hand side. So this frequency will become FC. This is FC plus 0.3 K. This is FC plus 3.5 K. This frequency is FC minus 0.3 K. This is FC minus 3.5 K. Similarly, on the negative side also, this frequency becomes minus FC. This is minus FC plus 0.3 K. And this is minus FC plus 3.5 K. This is minus FC minus 0.3 K. And this is minus FC minus 3.5 K. So this is the spectrum of DSB signal. Now to get the SSB signal, we will use a band pass filter. So in this case, I'm using a band pass filter to extract only the upper sideband of the signal. So what I will do, to generate the SSB, I will apply a filter. So this was the spectrum of DSB. This is FC, FC plus 0.3K, FC plus 3.5K. This is FC minus 0.3K, FC minus 3.5K. This is minus FC plus 0.3K, minus FC plus 3.5K. And this becomes minus FC minus 0.3K and minus FC minus 3.5K. Now I will have to pass it through a filter. So I'm taking a band pass filter which is having sharp cutoffs and having cutoff frequency exactly from FC plus 0.3K to FC plus 3.5K, similarly on the negative side also. So this is the filter. So once it is passed through this filter, at the output we will get only upper sideband here and only upper sideband here. So it will become FC plus 0.3K, FC plus 3.5K. This is minus FC minus 0.3K minus FC minus 3.5K. Now this is known as upper sideband and this is lower sideband. Similarly, this is also lower sideband and all this band is known as upper sideband. So what is the spectral spacing between upper sideband and lower sideband? So if we observe, this spacing comes out to be 0.6K or 600 Hz. Here also the spectral spacing is 600 Hz. So now instead of this ideal band pass filter, what would have happened if we have used a practical band pass filter? So the practical band pass filter will not have sharp cutoffs as shown here. Rather, it would have a smooth cutoff or smooth transition from pass band to stop band. So what happens if we would have used a non-ideal band pass filter or a practical band pass filter? So this is the pass band gain, and when it makes transition from pass band to stop band, it is not smooth, it is not sharp, but it is very much smooth. So this is a practical band pass filter. So you can observe in the modulated spectrum of voice signal, even if we would have used a practical band pass filter, the practical band pass filter also allows only single sideband or only upper sideband. It is not allowing the second sideband or the lower sideband. So whenever the spectral spacing between lower sideband and upper sideband is enough, which is 600 Hz here, in that case, even if we will use practical band pass filter, the practical band pass filter will allow only single sideband and it will not allow the second side band. So this is the spectrum of SSB signal with respect to the message signal of voice signal. So whenever the message signal is voice signal, the SSB modulated signal will have spectrum as we shown here. So the important point here we discussed, when voice signal is used, in that case, to generate the SSB signal from DSB, we can use either ideal bandpass filter or practical bandpass filter. The ideal bandpass filter will exactly allow the upper sideband, and it will have sharp cutoffs from pass band to stop band, while the practical bandpass filter will have smooth transition from pass band to stop band. And when it is making the transition, here we can say that it is just transmitting the single sideband, it is not overlapping with the second sideband. So for the practical bandpass filter, we will have to decide its roll-off factor such that it does not transmit the second sideband, and this 600 Hz spectral spacing gives us enough spectrum or enough frequency band so that we can design a practical bandpass filter with certain roll-off factor which will not interfere with the sidebands of the lower sidebands or the spectrum of the lower sidebands. So the spectral spacing between the sidebands of DSB is 600 Hz when voice signal is transmitted, due to which a practical bandpass filter with certain roll-off factor can be used to filter out exactly one sideband. Now if this spectral spacing is not 600 Hz or it is very less, then the designing of the practical bandpass filter becomes very tough, and in that case we might not be able to design a bandpass filter which transmits only single sideband. So here what we have done is the spectral spacing is 600 Hz, so we have designed a bandpass filter, and we have taken care that when it is making transition from pass band to stop band, it becomes 0 before the spectrum of the lower sideband starts. So we have make it here 0, and there is enough spectral spacing so that we can make the transition from pass band to stop band, from pass band to stop band proper. Now let us take the reception of SSB modulated voice signal. So let me make the block diagram of synchronous detector. So this is the block diagram of synchronous detector. The SSB modulated signal will be received here. We will have a carrier signal which is completely synchronized in phase and frequency, and we will have a low pass filter. This low pass filter will have spectrum from -FM to FM, and this is our H of F. And this FM here corresponds to 3.5 kilohertz, or the maximum frequency component of the message signal. Now I am making it as X of t and it is at Y of t. We know that X of t equal to SSBT into cos omega ct. So the X of F becomes SSB of F plus Fc plus SSB of F minus Fc by 2. So first of all I am making the diagram of SSB F minus Fc, which means I have to transmit the diagram of SSB modulated by signal to FC rightwards. So when I will transmit it to the FC rightwards, it becomes signal, it is minus 3.5k, it is minus 0.3k, and this spectrum is transmitted to, this is FC, FC is added to all these values, so it becomes 2FC plus 0.3k and 2FC plus 3.5k. Now I will draw the diagram of SSB of F plus FC. It means all the spectrum of SSB is transmitted to FC leftwards. It means we have to subtract FC to all the expressions which I am indicating. So I will subtract FC to all these values and we will get the spectrum something like this. So this will be 0.3k, 3.5k, and on the negative side it will be shifted to minus 2FC minus 0.3k, minus 2FC minus 3.5k. Now we have to add these spectrums and divide it by 2. So I'm not concerned about the amplitude, I'm just considering the frequency ranges. So once it is added, we get the spectrum of X of F. So in the spectrum of X of F, we got two frequency ranges, 0.3k to 3.5k, minus 0.3k to minus 3.5k, and another spectrum which is shifted to 2FC plus 0.3k, 2FC plus 3.5k, and similarly on the negative side, minus 2FC minus 0.3k, minus 2FC minus 3k, and lastly it is passed through a low pass filter. So this is our low pass filter, which is having the cutoff frequency of 3.5k. Now if it would have been a practical low pass filter, then cutoff from pass band to stop band would not have been this sharp, rather it would have been smooth. Similarly on this side also. So the output will become 0.3k to 3.5k, minus 0.3k to minus 3.5k, and this was the voice signal which we had transmitted. So by using SSB-SC signal, by using SSB-SC modulation, the voice signal can be transmitted and also it can be recovered at the receiver, because the voice signal, when it is made a DSP signal, it has proper spectral spacing between upper sideband and lower sideband, which is 600 Hz. So it is very much possible to generate a single sideband from the double sideband. So an SSB modulated voice signal has been generated, while at the receiver it also has been recovered at the transmitter. When voice signal was DSP modulated, it has enough, that is something 600 Hz spectral spacing between LSB and USB. So it is possible to generate single sideband by using practical bandpass filter. And once single sideband has been generated, so it can be transmitted as SSB SC signal, and the message signal can be recovered at the receiver. So this is at the receiver. So the conclusion is that for point-to-point voice communication, single sideband suppressed carrier must be used. So for point-to-point voice communication, single sideband suppressed carrier is used.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is Vishal Gate. Write my name and attach Gate to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code VishalGate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription, cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now, how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx, so you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.